Good evening to everyone. This is Dr. Polaiah, working as a professor in the Department of CSC Data Science. So today I would like to uh, explore the one of the important topic from image processing and analysis subject, which is as per the regulation of UG20, and this topic which I am going to be covered here is this one, the origins of digital image processing. So the topic which I have been selected here as the fundamental topic, fundamental of the image processing topic. This fundamental image processing topic which covers especially the origins of the digital image processing covers towards to understand the complete basics of the image processing. So what I wanted to say here very boldly, the origin of image processing is the topic which helps us to understand how can we define an image. If you define that image, how that define can able to help us towards to develop the different types of applications. That means here you are going to understand the complete topic with the help of following agenda. Number one, I'm going to be introduce you the selection of the topic, which the origin of the digital image processing. That is the origin of image processing. So how the topic they may be named, I'm going to introduce, and as well as I'm going to be concentrate here towards to understand the course's outcomes mapped with module 1. So how the course outcomes mapped with the module 1 also very important, because all the students who are listeners are here may going to be concentrate the completely outcome based education. So the topic which we are selectively selected to understand the complete topics in elaborately, so we had to understand detailed information. Okay, so the detailed information is here. We are going to be start depends upon the course objective connecting with that means mapping with the course outcomes. So this relation, the course objective and the course outcome relation will be covered only in the aspect of module 1. As we discussed in the previous class, there we discussed the detailed information about module 1 syllabus. From that syllabus, the first topic is which we are going to be discuss right now. So coming, the topic name is here, the origins and fields of image processing, which we are going to be concentrate as one of the topic from module 1. That is the third point which I am going to be concentrate today today in the agenda. Now coming to the fourth point, if at all we understood such a even it's a so-called complete basic topic, but the topic which we are going to be discuss right now is completely 100% connected to the one of the application. So which application may be today? The applications are connecting with our subject, that is image processing subject, is not only fixed with one field. It may be different field, nothing but interdisciplinary, nothing but multidisciplinary. So we are going to be prepared being an engineer student, which we are going to be concentrate for the development of such image processing for different fields, which we are going to be solve some of the industrial problems or any other type of organizations problems, or even social aspects also we can concentrate to this image processing. Next, coming to the, once we understood the list of the agenda, then we'll go to the next slide. What is my next slide? Is here. Before I'm going to introduce my topic, that is origin and field of the image processing. The topic which we are going to be gain 100% knowledge. The knowledge which we are going to be helps to achieve the course outcome. What that course outcome is here at the end of my daily lecture, we are going to be understand in terms of summarizing of the concepts of the fields of image processing, especially which we wanted to concentrate, digital image processing. Next, once we understood this, digital image processing is completely depends upon the origins and the fields of the image processing. The origin means what? That is what we are going to be discussed today. So coming to the topic, so here if I wanted to start the origin of the image processing, so here simply suppose, how can I define an image? What is the basic principle actually? To define an image, what I have to follow? What is the basic idea to define that? Yeah, being a human being, we are all here to understand this world. That means in front of us, the world is looking at us, and also we are looking at world. The meaning of real world we are looking is nothing but we are processing our brain. You are processing our completely brain signal is depends upon in our requirement way. So that means whatever you are seeing, that means whatever you are seeing, either in terms of 2D or 3D of the signal that can be observed, that can be observed by human visual system. So that means I'm simply going to be provide the definition of an image. An image is a 2D or 3D signal that can be observed by human visual system. Okay, so now once we understood this, immediately you are defined such a image. You are defined such an image. How you are defined as? By observing, being a human being, by observing this real world in terms of we are going to be see the visibility only in terms of in front of us, two-dimensional images process only. If at all you want to see that two-dimensional image processing converted into in your required manner in the sense you want to go in detail observation, then you are going to be use the same process of the signal in terms of 3D image signal. So that means we are going to understand this image, particularly image usually we used to define either 2D or 3D signal to the brain that can be observed by human visual system. That's what we are connecting to the brain. So once we connect to the brain helps you to process that image, whether this image is a 2D image or 3D image according to your required manner. So once we understood this image definition, then we are going to be convert that image into digitization. So digitization. Why we want to require digitization? Well, because here we want to develop an artificial digital image processing system. We wanted to develop artificial digital image processing system. Now, previously I defined the definition of image only in terms of natural. That means human being is a systematical processor person or a systematical processor. So that being it is a systematical process in terms of nature or naturally we are going to be define the image. But where you wanted to define the image to be used for certain analysis, that's what we are saying. Our title of the subject is digital subject is simply we call as image processing and analysis. When we need analysis, whenever we wanted to solve certain problems, then only we will go to the analysis of certain image. Okay, so that image right now, you wanted to proceed in terms of analysis of a particular image, we must have to concentrate in digitization. So you are going to be convert image into digitization. We are converting image into digitization, digital image. So how can we convert that? How can we do that? Yeah, we can do that, but in terms of representation of images by sampling in terms of time and space. Once again, I am repeating, how can I digitize a particular image, maybe a 2D image or 3D image. So I can represent that 2D or 3D image, represent that such a 2D or 3D images by using sampling in terms of sampling in time and space. So sampling is a method which we are going to use for converting image into digitization. Image into digitization. Now, when we convert, then we start the processing such a image. What for you want to process? You want to do certain operations. So that's what simply I'm going to define. Digital image processing is performing the digital signal processing operations on digital images. I'll repeat, perform digital signal processing operations on digital images. Next, we'll go ahead with the help of such a fundamental definition of the image. Immediately, we are going to define based on the previous class. Yeah, we are going to be process that. The meaning of processing, image processing, maybe a digital. So how can we process? Especially we are processing of that digital image in terms of image data for the sake of storage, transmission and representation of particular perception. What is the perception is here? Automation mission perception. Autonomous mission perception. So you have to understand this again. Autonomous mission means taking it is a mission. Okay. So being it is a autonomous mission, it takes the image data as a input and it provides the output again as a image. But this image you may be providing in your required manner, depends upon this operation of the mission. So to process this mission, so we are going to be store your image data and transmit and as well as represent for your process. The best example is today ATM center. Or we call this ATM is HMI. That means human machine interface. So we are going to be process this ATM by the principle of HMI. Nothing but you are going to be interact with the mission, ATM mission, in terms of what we call taking the input signal and process and doing. What is the input signal of ATM? So far we are using numerics, nothing but pin numbers. But whereas here we are going to process with some facial recognition or maybe thumb impressions or maybe eye contact, something like that we can use in future. Then what is the use of that? So especially it helps us to save and security of the information. Next, coming to the topic, once we understand the importance of digital image processing, then that origin being an engineering, especially in the specialization of image processing, we are going to be start the origin of digital image processing. How can we start? So it is a field actually. It is a field of digital image processing, refers to process digital images by means of digital computer. I may say that simply it is nothing but any digital unit. Any digital unit is nothing but one digital computer. Today, even your personal mobile is processing with certain patterns to open that. Also digital. So that is one we call as a mini computer, mini digital computer, mini digital unit, I can say, but it is our personal we are using. So that's what the origin of digital image processing is started. Only depends upon the requirement of the human being. That's what we connecting 100%. This digital image processing is to connect only origins of digital image processing. One to another steps are helps to process the input signal and gives to the requirement. But coming to the here, such an image processing is not a simple process. We have to define such a maybe a 2D dimensional image you are taking. If at all you are taking 2D image, we have to concentrate that 2D image, that is two-dimensional image, we have to prepare in terms of data. So image data, because it is a signal. It is image nothing but a signal. So that signal we are going to be represent in terms of one of the objective function. Then the name of the objective function is f of x comma y. Then that name of the object function is f of x comma y. So where x and y are the spatial plane coordinates. So simply we are saying like this. So here there is an image. Here there is a image. Whatever image. This is a x-axis. This is y-axis. Okay. So what is your meaning of that? Being it is a plane. Okay. So in this x and y plane, we are going to be see the f of x comma y value in terms of amplitude is f. So amplitude will be vary y-axis and x values will be vary depends upon your number of pixels of the image. So once we understood this, simply we says that an image may be defined as a two-dimensional function f of x comma y where x and y are spatial coordinates and the amplitude of f at any pair of coordinates x comma y is called the intensity or gray level of the image at the point. So particular point you may be going to be understand in terms of gray level. So we are going to be discussing in detail about gray levels later on. First of all, we have to understand the origin of the digital image is started towards to define such an image in terms of coordinates x and y and finding the f of x comma y as objective function value in terms of amplitude. Next, these amplitude values of particular f are always, all values are finite values only. Okay, that finite values may be a discrete quantities or we may call that in terms of digital image values. Okay, so how we maybe get these values later we are going to discuss in detail. Next, coming to the once we understand such a origin of the digital image processing, we are defining only in terms of 2D image. Maybe we define this one 3D also. Maybe define as a 3D also. That we will discuss later on. Okay, that we will discuss later on. But only we wanted to understand here such a 2D image. We are going to be define such a 2D image in terms of pixel. So your origin is started right now. That means you are reading the image. You are going to be read the image. So your 2D image you are going to be read here is this is y-axis, this is x-axis. Okay, y-axis and x-axis. So if you suppose you are keeping what I am saying is here, we are going to be keep simply like this. Okay, so in this actually let me to draw an image which always usually used to define in terms of x and y. Okay, in terms of x and y, that x and y values, that means y and x values, we are going to define this image. Okay, this is called image. Okay, And this image we are going to be defined in terms of rows and columns. In terms of rows and columns. In terms of rows and columns. So rows will be always, as we know, horizontal, and columns will be, values will be vertical. So the image data, okay, we are going to be defined with the help of x and y coordinates in terms of pixel. So now we wanted to get another important origin point is here is how the image can contains pixel values. Pixel values. So that means here we are going to be defined that pixel value is nothing but which we are going to be defined only in terms of xy coordinates only. For example, let me to take here as I drawn here, one is horizontal, another one is vertical. Here it is vertical. Vertical knife. So how I may be connecting horizontal with vertical to get certain value which is located at particular origin. Now, so you can catch my point. Origin, the term origin, how it may come right now. So it come right now to find out the pixel value at a certain place. Which place right now we are going to be get that? Which place? That is one of the origin of the image helps you to find out the value of the pixel. So this pixel value now defining is helps x and y coordinates plane only. So once you understood this, and here this value to this value, this value to this value, this value to this value, the relationship one pixel with another one pixel with another pixel, how that we used to call as neighbors of the pixel, neighboring of a pixel, neighbors of a pixel. That means one pixel to another, one pixel to another. We are connected actually. So based on your connecting, now whose coordinates are given in terms of standard way. In terms of standard. So we connected, first one may connected like x plus 1 with y. What is x plus 1? Is the x coordinates and y coordinates. X coordinates is this and y coordinates. So we wanted to define a pixel values of a particular image with x comma y coordinates only the in terms of neighbors, in terms of neighbor of a pixel. Okay, we'll define x plus 1 comma y. Like that, we are going to be define x minus 1 comma y, x comma y plus 1, x comma y minus 1. What are these? These are the helps us towards to understand a pixel how can vary only in terms of neighbors of a pixel. So we are finding one to another. That means simply we finding one to another means a set of pixels called four neighbors of P, okay, denoted as n to the power n suffix 4 of P. What is a P? Pixel. What is a n? Number of neighbors. How many neighbors we have here? 4. So n suffix 4 of P means you are going to be find out the number of pixels of relations of neighbors of the pixel with respect of 4 cells only. 4 neighbor cells only. So that is the n to the power n suffix 4 of P. So once you understood this, then immediately each pixel is a unit distance from x comma y and some of the neighbors of P. P is lies outside of the your digital image if x comma y is on the border of the image and border of the image. So it helps us totally to find out the pixels relations. So coming to the point, as we understood right now, okay, so that numbers of the pixels neighbors, okay, how that composed of a finite number of elements, each of which has a particular location and value. That's what I told you. So neighbors of a pixel helps us to find out, that means to understand each of which has a particular location and value. That means I can say here simply, you find out here, this is maybe you say as x minus 1 comma y or x plus 1. So this tells you location and the value. So that means you have to understand, to find out the location and the value of the particular neighbors of a pixel, what are the elements can help you to find that. So we can understand that elements are referred to as a picture, particular picture, in terms of elements, image elements, pulse and pixels. These are the elements help us to find out the origin of the particular image pixel value. Okay. So now, based on your understand that pixel value, we can go ahead towards to term most widely used denoted elements of the digital image is pixel. So pixel is the term most widely used to denote the elements of a digital image. Now, I'm repeating once again in terms of continuation. Once we understand to define such a pixels of the image, for example, here D. What is the D? I said D. D is the dimensional of the pixel which helps us to find out the location and value of the neighbors of a pixel. That is 4. D value we can define. So ND of P is now simply you can define N suffix 8 and P. Okay. So that means we can say that the 4 diagonal neighbors of a pixel P have the coordinates are here, number 1, 2, 3 and 4. These are the 4 diagonals. So what do you mean D? D means diagonal. Okay. So diagonal means you are going to vary your number of your pixel values in terms of neighbor of a pixel is here. So that means you are denoted by as a N suffix D. Sorry, this one is suffixes. This one is suffixes. Simply we write N suffix D of P. Try to correct this. Okay. So that is the what we wanted to understand. So continuation of this ND suffix of P, these points together 4 neighbors are called the 8 neighbors of the pixel. Called the, how we can call N suffix 4 of P. If 8 neighbors means we call as N8 suffix of P. So if some of the points N is this one also N suffix D of P. Okay. So here also N suffix of 8. Both all outside the image of neighbors of the pixels if x comma y is on the border of the images. So we are going to discuss in detail this point with a certain application later on. Next, coming to this digital image processing, which we wanted to define in terms of 2D image. Okay, 2D image to read such a locations of the pixel, neighbor of a pixel, location and value we are going to find. How in this sense, for the best example is I'm taking here a 2D image, which is keeping in terms of x comma y coordinates. Okay, so before I'm going in detail of this, I'm going to compare this with the help of 3D world also. You mean 3D world means, that means 3D world means the dimension of an image that you capture in terms of 3D. Okay. So when we capture that and comparing with the 2D, okay, so you maybe define that maybe a 2-dimensional signal, or if you require that 2D as a 3D. Okay. So it's also 3D signal only. It is also 3D signal only. So simply you can say that an image is a 2-dimensional. That why we also define an image as a 2-dimensional signal is here an image does not have depth. Just have a look at this shown image below. Just have a look. So what I wanted to say here? I'm going to say here, compared to 3D with 2D, 2D is easy to read, but 3D means we are supposed to go beyond the point. Beyond the point in the sense from 2D to 3D. So how can we go that one is, let me to explain with some more examples with the shown figure. So what is this figure I'm saying is HMI based digital image processing. What is HMI? HMI means Human Machine Interface. Human Machine Interface. This is called HMI. Okay. So this HMI, for example, you can see here, the image which I am showing here is with the help of signals, a human being signals is controlling the, maybe a drone is controlling the, number one is drone. Number two is he may be controlling the complete flight. Okay, what do you mean this? So your hand gesture signal we call as hand gesture signal. Hand gesture signal is the signal may you define in terms of 2D, two-dimensional image signal towards to represent in terms of digitization. That digitized signal gives you 100% accuracy for running either a drone or a flight or etc. So coming to the point, if suppose for example, even HMI is also helps you nowadays, even now, we are capturing the images in terms of face recognition. The group of peoples are roaming in and around. For example, where we can find a certain group of people, especially at certain stations. What are the stations we know? We know one is a railway station. Another one is a bus station. Okay, like that. Some of the places which we can find out this type of crowd people. From that crowd people, if anybody want to find in terms of missing image, we can find. How can you find? Naturally, a human want to find such a missing person faces. So by natural you want to proceed, it may take too much time, too difficulties you have to face. But by sending the digital image processing based drone, then it is easy to find out where is he located at particular location, and also we can find out where he is standing, valued dimensional position. We call as position. So valued dimensional position value we are going to find out this. So that is what we wanted to find. So coming to the another person who is here. Nowadays you are using with the cameras. That means you wanted to shoot some information. You want to measure certain laser light based measurements. So through image processing we are going to capturing image in terms of distance, capturing image in terms of damages. That means you are going to see such application, especially in terms of disaster management processing. So that means you are going to find out after cyclone effect or after earthquake affected places, you may find out through human interpretation process only. So once you understood this, immediately even I'm repeating same concept. From the group of the people you want to find out particularly in terms of 2D, okay, or you want to go with 3D, you may have extended the technology. So that means your digital image processing will play multi-role. So that is very important here. Next, coming to the at the end of this session, I want to repeat. So the same origin of the image processing is also concentrating not only one particular application. It also concentrate more than 5 or 10 applications at a time. So that means a device which you are defined not only used for the particular of medical image processing, it also used for the control system. It is also used for the surveillance position monitoring system. It also used for the law enforcement processing system. It is also used for the defining of artistic effects. What I wanted to say based on this, so the origin of the signal which we are defined in terms of 2D image signal helps at a time towards to help different applications. Okay, so with this I'm going to be conclude for the prepared content. I referred one of the textbook is first one. So I'm thank you for your patient listen. Really, this session may be very useful for you. If at all you wanted to interact with me, kindly interact with me, and you can clarify your doubts. And thank you so much for your patient listen. Once again, thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.